Hey, Dad, can I go hang out with Lily?
You can't hang out with Lily until your calculus homework is done.
Oh, brother, this guy stinks!
Today we're going to be solving problem number 9 on page 265, the perimeter of 80 meters. This is an optimization problem, so we're going to need to find two equations, a primary and a secondary. Since we were given the perimeter, our primary equation is going to be area. As shown right here, area equals length times width, so this is our primary equation. A secondary equation must equal the total, so we're using the equation for perimeter, which is 2 length plus 2 width equals 80. Now we're going to solve for one of our sides, and I chose length. So now we have to isolate the length by itself. Start by moving the 2 width over to the other side, then divide both sides by 2. Now our length will equal 80 minus 2 width divided by 2. Now that we have our length, we're going to plug this into our primary equation for area to equal 80 minus 2 width times width divided by 2. Now we take the derivative, which is 80 minus 2 width times 1. You don't have to show the 1. All divided by 2. Now we simplify, which gets 40 minus 2 width. Now all we have to do is set the equation equal to 0 and solve. After setting the equation equal to 0, I moved the 2 width to the other side. Now to isolate the w, divide both sides by 2. Now this means width equals 20 meters. Now that we found what our width is, we're going to plug that in to our length equation, which is our secondary equation, which will give us 80 minus 2 times 20, all divided by 2. 2 times 20 equals 40, and 80 minus 40 equals 40. So that'll give us 40 divided by 2, which means our length is also 20 meters. And our final dimension is 20 meters by 20 meters.
Yes, I can finally go see Lily. Oh, hey Lily. Hey girl, come on. So, how was that calc problem?
Lily, it was so horrible. It took me forever to do. Like, I just couldn't get it right, and it just kept going, and then it just kept going and kept going. Lily, where'd she go? Ah! I can finally learn how to do calc.
3 days later.
Where are we? I don't know. Oh, you're finally awake. I have a mission for you. I need you to solve a calculus problem.
Liv?
I got this. It's the mean value theorem.
To do number 58 on page 329, we need to start by writing out the problem. The problem is f of x equals 10x minus 2 to the x with the boundaries of 0 to 3, and this is the mean value theorem. We first have to start out by creating an integral with our boundaries from 3 to 0, and then we have to write out our equation, and then equals, since this is the mean value theorem, we have to turn all our x's into c's, so this equals 10 minus 2 to the c, and then subtract our boundaries, which would be 3 minus 0, which equals 3. After we do that, we have to do our antiderivative, which would be 10x minus 2 to the x over ln of 2, with the boundaries from 3 to 0. And then we also just want to leave this just like this because it'll be easier later to divide and subtract. Step 2, now we have to plug into our integral. So f of 3 minus f of 0, we get 10 times 3 minus 2 to the third over ln 2, and 10 times 0 minus 2 to the 0 over ln 2. So once we do all that, we end up getting 19.91. The next step is to solve for c. So since we completed our integral and got that number, then we're going to just set everything equal to 10 minus 2 to the c times 3 to try and solve for that c. So to do that, first we're going to subtract by 10 on both sides. And then we get this. And after we do that, then we're going to divide out that 3. And then after we do that, we want to get rid of this negative here so we can use ln2 to get the c down. So what we're going to do is divide by -1 to get the negative out of there. And that gives us this. And then after we get all of this, then we're going to take ln of both sides, which cancels out that 2 and brings that c down. So that leaves us with c equaling 1.887.
You cracked the code! Yes! Oh, I can't find it. Dinner is served. Oh, dang it. Don't run! Oh.
Then it just kept going and kept going. Lily, where'd you go? Then it kept going and it just kept. Lily, where'd you go?
Me? Oh. Good. Oh, finally awake. Okay, ready?